Today we are going to solve equations involving radicals. And to do that, let's first just solve an equation that we've seen before, something like this. Okay, now we could pretty much do this in our sleep if we wanted. Can you see that? Is that, I'm gonna use
I was going to ask you if you could use a different pen.
yeah, that's looks great here, but then when I looked in the camera, it looked terrible. So
There we go.
-7 = 3. Now we could do this in our sleep, but because we're doing this in order to get a feel for something, I want to be very explicit here, right? Like what we want to do anytime we have an equation, we could think about this as, you know, I've said this before, it's like if you put on your socks and then you put on your shoes, in order to undo that thing, you have to take off your shoes and then take off your socks. So when we're looking at this and thinking about orders of operation, knowing that we're trying to get the x by itself, we look at the x and say, what's the first thing that happens to x? Well, the first thing is it gets multiplied by 2.
Mm-hmm.
And then it gets a 7 subtracted from it. And so we do it in the opposite order, working from the outside in. So since the last thing that happened was -7, the opposite of -7 is what?
+7.
+7. And so we take off our shoes. That is, we undo the last thing that was done first, giving us 2x, I guess, +10. And now we're in the situation where, okay, now it's the socks, right? Now it's the first thing that happens to x and we undo that. How do we undo multiply by 2?
Divide by 2.
Divide by 2. It's we use the inverse operation to undo the thing. Okay, and we get x = 5. And then this is, now normally we just stop here, right? And because, yeah, but what we're gonna really want to do today is check our work, because interesting things happen with radicals. And it's just like when we were working with rational equations and you have something like this, and you find that you get 2 solutions and one of them is -1, and you had to go back and say, uh-oh, if I plug in a -1 back here, bad things happen. And so we can't do that. We have to do the same thing with when we have things involving radicals. We have to go back and plug in to make sure it works. In this case, we take x + 5, plug it in right here. We get 2 × 5 - 7. 2 × 5 is 10, -7 does indeed equal 3. And so that checks and we're good to go. So let's do something very, very similar here. Okay, so going through the same reasoning, right? I'm going to look at x and see what's the first thing that happens to x. If I'm all the way inside at x, I'm looking, okay, he's not getting multiplied by anything or nothing's being added or subtracted to him. So I'm going to work my way out and say, okay, then the first thing that happens is x gets a square root taken. And then he gets a 7 minused off. And so that would be socks and shoes. The shoes, the last thing done would be -7. And so we undo that. How?
+7.
+7 on both sides, okay? And so that gives me the square root of x is equal to 10. And now, okay, what happens to x? He gets a square root taken. How do we undo square root?
Square it.
Square it, right? And this is the key here, right? Is like the opposite of multiplication is division. And so we just do the inverse of it to undo it. Same thing here. This could trip you up a little bit if you think too hard about it. But if you just think, wait, a square root, the opposite of square root, like the way we even defined it was that it's the opposite of squaring something. So to undo this, we are going to square both sides. And so let's do that. that the whole reason we did this here on the left-hand side was to make the x pop out. And so we get x by himself. 10 squared is 100. And so I think, okay, we should be good here. We got to go back and check it. And so I'm just going to plug him in right here. What's the square root of 100?
10.
It better be, right? And some of these, it's obvious, like especially in this case, you're going to go, why am I checking this? You'll see in just a second. It's so important that we do. 10 minus 7 does equal 3, and we're good to go. That is what we should have. And so that's the idea with these guys. Very simple in this case. Now, you're going to run into this stuff. Am I good to erase this stuff?
Yeah.
Okay. Oh, we are recording. Okay, good. Okay, so check this out. Now, let's do the same thing here with this equation. And the boy is awake. Okay, what's the first thing I want to do to solve this equation? In other words, I'm trying to get x by himself. What do we do?
Subtract 5.
Yep. Almost the same thing here. So we minus 5 from both sides. We get root x equals 3 minus 5 is minus 2. X gets a square root taken. How do we undo square root?
Square it.
Okay, so I'm going to square both sides of the equation. And that gives me x equals what?
4.
Positive 4. And so I go, okay, I'm good to go. I have my answer. Let's check it. So the square root of x, we're going to plug in a 4. Square root of 4 plus 5. What's the square root of 4?
2.
What's 2 plus 5?
7.
Is 7 equal to 3?
No.
Uh-oh. So that's what can happen with square roots. It turns out when you run into something like this, we're going to say there is no solution. And usually that is the case. In fact, I think every time you run into something like this with this problem set, there will indeed be no solution. Sometimes it's because, yeah, well, we're not going to get into that. But if you think about what this is, right, if we go back to this before we squared both sides, we had the square root of a number is equal to a negative number. No, it's not. That's not the case because we've defined the square root to be a positive number always, right? That's how we define principal square root. Now, in certain contexts, this might change, and that's what I mean by sometimes you might end up with a solution, even though it may look like this, but we are not even going down that road right now. That'll come later. When you're going from roots, when you have roots in your equation, when you run into something like this, that's a just straight up contradiction, and that is not true. And so there's no solution to this. It's impossible. Okay, can I erase this? Can we move on?
Yes.
Okay, so. Now, let's take a look at this. This is from the problem set. This is number 2. And it is the square root of x plus 3 is equal to 6. Okay, now let's think about this. Looking at the innermost stuff, because I want to undo things. Boy. I look in the inside and I say, okay, well, the first thing that happens to x in this case is plus 3, because that is, we could even think about this if we wanted to. We could think about this as x plus 3 raised to the 1/2 power. And so this is, we could always think of a root as this is in parentheses. And technically it is in parentheses. So the innermost thing is the x plus 3. So the first thing that happens is x gets 3 added, and then he gets a square root taken. And so that would be the outermost stuff. What's the first thing we need to undo in this case?
Okay. Plus 3.
Well, think about it. First we plus 3, right? And then we square root.
Oh,
Like, yeah, you put on your socks, then you put on your shoes. We have to take off the shoes first.
okay.
The outermost thing has to be taken care of first. So how do we undo square root?
Square it.
Yeah, so we're gonna square both sides right here. So I'm gonna square both sides. That undoes that and gives me x plus 3. What is 6 squared?
36.
36. So I've taken off my shoes. Now how do I take off my socks?
Minus 3.
Minus 3 from both sides. There we go. That gives me x is equal to 33. The last thing we have to do is what?
Check.
Check it in the original equation. And so the x is 33. 33 plus 3 is indeed 36. And what's the square root of 36?
6.
6. And 6 does equal 6 last time I checked. So we are good to go. That will be your answer right there. So this is very tricky, right? Like there's a big difference between the square root of, there's a big difference between the square root of x plus 3 equals 6 and the square root of x plus 3 equals 6. In this case, we'd say, well, and really like it's the same kind of thing as when we had say 2x plus, we'll do 3 equals 6 versus 2x plus 3 equals 6, right? Because this, when I look at this, I can see, okay, the first thing that happens to x is the times 2, then it's the plus 3, so I need to undo the 3. This I would look at and say the first thing that happens to this is plus 3, then it gets multiplied by 2. So in this case, I would undo the multiply by 2 by dividing first. And in both cases, what we're trying to do is get this symbol by itself. And so it's similar here. It's similar when you have equations like this. The goal is going to be to get this root symbol by itself. And so in this case, I'm trying to isolate this because I know I can undo it by squaring it. In this case, it's already isolated, right? It's like, oh yeah, that symbol is all by itself, and then I'm going to work my way in. And so you'll have plenty of work on this. So are we good with this example?
Yes.
Okay, ready to erase. And yeah, now we're gonna do this. Excuse me. Okay, I'm gonna modify this one a little bit. 2y, it was plus 1, yes. How about a little bit? Okay, now, oh boy, there's a lot going on here, and we could think about this 2 different ways. The way I think about it when I'm doing it is like, okay, that's my goal. I'm trying, and by the way, we're solving for y, in case you didn't figure that one out, right? We're solving the equation for the only variable that's in it. I want to get this guy by himself. And so without going through like all the different steps, I could just see that, well, ultimately this symbol, if I get it by itself, I'll be able to square both sides and get rid of that symbol and then keep working my way in towards y. But if I wanted to be explicit about this, like when these start to get really complicated, I find that it's nice to just kind of, I'm going to write a record of what happens to y. You know, the same kind of thing, like you put on your socks, then you put on your shoes, then you put on your snowshoes, In order to get rid of that, you take off the snowshoes. And so that's what I'm going to do here. What's the first thing that happens to y in this equation?
It gets multiplied by 2.
Okay, so multiply by 2. Then what happens?
Then you add 1.
Then it gets plus 1. Then what happens?
Then it gets the square root.
Then it gets a square root taken. Then what happens?
Then 1 is subtracted.
Then minus 1. Okay, and then after that happens, it should equal 12. So to undo this, we're going to go in the opposite order and figure out. So what is how do we undo minus 1?
Plus 1.
We plus 1. Then how do we undo square root?
Square it.
We square it. How do we undo plus 1?
Minus 1.
We minus 1. How do we undo multiply by 2?
Divide by 2.
Divide by 2. Okay, so now normally you won't write all this stuff out, but when it's so bad that you can't really see what to do, I find it's really helpful to just kind of write this stuff out. It can help. In this case, right, the way that this looks in my brain is I look at this and go, okay, that's my goal, working my way out. That's the last thing that happens. And so I'm just going to keep that in my mind right now and say, that's the last thing that happens. And so how do I undo that thing right there?
Plus 1.
Plus 1 to both sides. Okay, so plus 1 to both sides. That gives me 13 on the right-hand side and this right here. Again, I kind of go back through these steps and say, okay, 2 times y, then plus 1. Oh, then square root. So how do we undo square root?
Square.
We square both sides. That makes this thing pop out. That's the reason that we did it. And what's 13 squared?
169.
Oh, good. Yeah. Okay. I had to scratch that out last night. Good for you. Okay. Now I'm looking at this equation saying, okay, y gets multiplied by 2. Then he gets the plus 1. How do we undo the plus 1?
Minus 1.
And that gives me 2y equals 168. How do we undo 2y?
Divide by 2.
Divide both sides by 2, and I get y is equal to, let's see, that would be 50 and 34. 50 and 34 is 84, I believe. Yep. Okay. Nice. Okay. Now just notice that indeed we ended up doing this in this order, right? We plus 1. Yep. Then we squared it. Yep. Then we minus 1. Yep. Then we divided by 2. Yep. Okay. It was all consistent. Looks good. What's the last thing we need to do?
Check.
We better check this. So I'm going to plug in right here and see what that equals. I'm plugging in 84. 2 times 84. Well, we just did this, but let's just 168 plus 1. Okay. Minus 1. 168 plus 1 is 169. Minus 1. Square root of 169 is 13. Minus 1 does equal 12. 12 equals 12. Good to go. Okay. Ready to move on?
Yep.
Okay. So no surprises really yet. This is all pretty straightforward stuff. Okay, now another thing is when we have this guy. This is problem 14, and it is the cube root of y is equal to -4. Now what do we do?
Cube them both.
We cube them both, right? Because cube root means it's the opposite of cubing. And so if it were y times 2, we would undo it by divide by 2. This is y, the cube root of y. So the way to undo cube root is to cube it. And so we're going to cube both sides. That's the thing that makes y pop out. What is -4 cubed?
-64.
There you go. Okay. Now we better check it. And so I'm going to put in the cube root -64 and say, uh-oh, wait a minute, a negative, but it's perfectly fine to have a negative with an odd numbered root, right? That's perfectly fine. Like you can do that. That makes sense. And indeed, this is really trivial because we just computed what that is. Like we know that this is -4 cubed. And so, yeah, that is what makes that guy pop out. Yes, it works. Look at how different it would be if it were the square root of y equals -4. We're kind of back in that one of the situations that we saw earlier. We would have squared both sides. We'd square both sides, we would get a y that pops out. -4 squared is +16. And so you say, okay, I'm going to plug this guy back in. Square root of 16 is +4 is not equal to -4. Uh-oh. And so in this case, right, when you have an even numbered root of something equal to a negative number, call it k, this ain't going to work ever, right? And I would say when you end up with something like that, an even numbered root equal to a negative number, you could just stop and say no solution. But let's not do that. You'll see why in a few weeks. Like we're gonna just go with it and then plug it in and see for ourselves. We really want to reinforce this, that yeah, when you have a even numbered root equal to a negative number, that ain't gonna work. So I would like to see the check at the end that, yeah, that does not work. So, but with odd number roots, that's perfectly fine. You could have a negative number go into an odd numbered root and the answer is a negative number. So that's perfectly good. Okay, good to go?
Yes.
Okay. Okay, so let's do this real quick. So no roots here. Let's just do this 1 over x and let's solve for x. What am I going to do?
Multiply both sides by
What?
x, right?
Yeah, right. I mean, it's down there. We want to get it by itself, but it's downstairs, so let's multiply by it. So yeah, we're going to multiply both sides by x. I'm going to write that as 3x equals 1. Okay. Then what do?
Divide by 3.
Divide by 3. And we get x equals 1/3. And so now I'm going to check it in the original equation and say, okay, 1 over x, that's the same as 1 over 1/3. Divide by a fraction is the same thing as multiply by the reciprocal. And the ones cancel, or you can just think about them as just equaling 1. Any way you go about doing it, you do get that 1 over x is equal to 3. You're good to go. Okay. So similarly, if we were going to do number 20, we have 3 equals 1 over root y. Guess what we're going to do first?
Square the Wait, hold on.
You could. If you really want to, you could.
I guess just multiply by the square root of y.
Exactly. So like what kind of trumps everything is if you have a variable in the denominator, or if you just ever have denominators in an equation, kill the denominators. It almost always makes your life better. And so to kill the denominators, we're going to multiply both sides by the square root of y. That gives me 3 root y equals 1. Then what do?
Then you square the no, then you divide by 3, right?
There you go. There you go. Now you could, if you wanted to, square both sides right now. I think I like to just get that root by itself. If you can, you'll see in a minute, you can't always get a root by itself, but if you can get a root by itself, get it by itself. So we're going to divide by 3. And kind of thinking about the way we were doing it last time, it's like, what happens to y? Well, first he gets a square root, then he gets multiplied by 3. So I'm going to unmultiply by 3. I'm going to divide by 3 first. Then I'm going to unsquare root. How do I unsquare root this guy?
Square it.
I square both sides. That gives me y equals what?
1/9.
Yes, good. Good. Because 1/3 squared is 1/3 times a third. Just multiply numerators, multiply denominators, you get 1/9. There you go. And so now we're not done. We got to check this guy. So I'm going to erase this stuff here and check him over here. Our original equation was 3 equals 1 over the square root of y. So I'm going to replace y right here with 1/9. Now I'm going to say, okay, that's 1 over, rewrite that as square root 1 over square root 9. Square root of 1 is just 1. Square root of 9 is what?
3.
3. And so I have 1 over a fraction. Why don't I write that as 1 over, 1 times the reciprocal. The ones cancel and I get 3. And so yes, 3 equals 3. Check, we're good. Y equals 1/9 is my answer. Good to go?
Yeah.
Okay, now this is where it starts to get very difficult. This is number 30. The square root of x minus 9 plus the square root of x equals 1. Now up until this point, we've been able to get a square root all by itself and just square it and get rid of it. Well, now we have 2 square roots to deal with. Both square roots have the variable in them. And in this case, where you have multiple roots, it's easiest usually to get these roots on opposite sides. If we wanted, we could just square both sides and just plug along, but it usually ends up being easier to split these roots up on opposite sides. So what I'm going to do is choose one of them to take over here. How about that guy? Let's just get this guy right here, that over to the left-hand side by subtracting from both sides the square root of x. That leaves me root x minus 9 on the left-hand side. And on the right, we have 1 minus root x. And whenever you have square roots in your equation, we're always going to have to undo that by squaring it. And so let's square both sides. See what happens. The left-hand side's easy. When I square this guy, what do I get when I square this right here?
X minus 9.
Just x minus 9. That's why I did it. It made that thing pop out. But when I square this side, oh boy, what are we going to have to do?
Foil.
Yes, we're going to have to foil this bad boy. And what do we get? What's first?
X. 1. Hold on, sorry.
Okay, no problem, no problem.
First is 1.
1.
Minus the square root of x.
Uh-huh. And then
Minus the square root of x.
for a total of how many square roots of x?
2.
So how about minus 2 root x, okay?
And then plus x.
Plus x, okay. Now what's nice in this case is we happen to have the same number of x's on the right and on the left, and they're going to cancel out. In general, that's not going to happen. We might have 2x over here and 5x over here. But in every case, no matter what happens, we are still going to want to isolate the square root. And so I want to kind of break this down. The first thing we did was we separated the roots, right? We got them on opposite sides. Then we squared both sides. Now we want to isolate remaining roots. That's what we're doing, because that's kind of the idea, like how we've been doing things is the root's the problem. If I could get this x to pop out of the root, that would be great. But I'm not just going to square this entire thing because that's going to look ugly. If I isolate all the remaining roots on one side, that will probably make my life easier. So let's get everything over on that side. When I subtract off an x, they happen to cancel out. That's great. How about subtract a 1 from here to give me a total of negative 10 over here equals negative 2 root x. Now that looks nice. That's something I could deal with, right? What happens to x? Well, first he gets a square root, then he gets multiplied by negative 2. So how do we undo this guy?
Square it.
Wait a second.
Oh, wait, no. Sorry, I had it backwards. Divide by 2.
Divide by what?
Negative 2.
Negative 2. There we go. So I'm going to divide both sides by negative 2. And now that gives me a positive 5 on the right-hand side. It gives me a square root x on the right-hand side. And now what?
You square both sides.
Square both sides. Oh, no. And that gives me 25 equals x. Are we done?
No.
No, so I'm going to go ahead and leave holes where my x's are. Okay, I'm going to replace this with 25. So we have 25 minus 9 and the square root of 25. So what is 25 minus 9?
Simple math. 16.
I know. I swear, when I did this last night, I literally used my fingers. I was like, well, hold up. I know. Okay. And then so we have the square root of 16 plus the square root of 25. What is the square root of 16?
4.
What is the square root of 25?
5.
What's 4 plus 5?
9.
Is 9 equal to 1?
No.
Oh boy. So this, all that, just to find out, no solution. You're gonna run into that. So finally, no solution. That's gonna happen. Okay, are we good to go to the next example?
Yes.
Okay. Okay, this next one, oh man. This is it's at least the hardest one that I've worked out. You might have some harder ones. This one's gonna be so hard. I'm well, okay, let's just work on it. So we have, this is number 36. This is the square root of 6x plus 7 minus the square root of 3x plus 3 is equal to 1. Okay, again, we have this situation where we have two groups of roots, and it will be easier to go ahead and split them up. So I'm going to choose to keep the root 6x plus 7 on this side, take that guy to the other side by plussing, and so we're going to plus 3x plus 3. You following?
Yep.
Okay, so I have a root isolated. I could get rid of that root by squaring it. So let's square this guy. If I square that guy, I gotta square that guy. Squaring the left-hand side gives me 6x plus 7. And what do I get on the right-hand side?
1
1
plus 3x plus 3. The square root of, well, hold up. First,
in the order, first, outer, inner, last.
yeah, so 1 times the square root of 3x plus 3 is just 3x plus 3, right?
Right, and then plus 1 times the square root gives me a total of how many of them?
3x plus 3.
Well, how about 2?
Oh, no, I'm doing it wrong. So 2.
2 of them. I like to, when I'm doing stuff like this and it's real complicated here, I like to just do scratch work right here. I'm going to do my inner, outer. I'm going to go, okay, 1 square root plus another 1 square root of stuff, giving me a total of 2, whatever the square root is. And then when I go to finally write it out, I'm going to then put that stuff in. I just really lazy. And so the outer and the inner give you, in this case, 2 times that. And now what's the last give us?
3x plus 3.
There you go. Okay, now this is like what I was saying before. It's not all, the last one happened to work out so that we had the same number of x's on both sides. We don't have that anymore, okay? So what we want to do is isolate this guy right here. And so let's do the whole numbers first. We have a 1 and a 3. Subtracting all of them off, I could subtract off a 1, subtract off a 3 by subtracting off a total of 4. That gives me 6x plus 3 on this side. Now let's get the 3x over there. So I'm going to subtract off a 3x from both sides, leaving me a 3x over here. Now, this is where what we've been doing up until now, and I've made a big point of this, is like we need to isolate the entire root by itself before we square this thing out. I'm going to do this, and you're going to see why you don't always want to do that.
Mhm.
But let's go. Let's just try. Like if this happened to be, say, 6x plus 6 equals this, that would be a great way to go about it. We'd say, well, let's get rid of that 2 by dividing by the 2. Oh no, this is going to look really ugly. And I mean, I could leave it, put that all under 2. But this is how I would just naively go about doing it. In which case, like I said, this is going to get so ugly. Okay, so I just think, okay, I'll just go on along this way and just keep doing this. How do we undo this guy? What do we need to do?
Square it.
Square it. And so I'm going to square this side. And I'm going to have to go, boy, that's ugly. Oh no. And so, all right, I'll just go ahead and write it out. 3/2 x plus 3/2 times itself is 3/2 x plus 3/2. 3/2 times 3/2 is 9/4. X times x is x squared. The outer gives me 9/4 x. The inner gives me 9/4 x. And the last gives me 3/2 times 3/2 is 9/4. I could add these together. 9/4 plus 9/4 is 18/4 or 9/2. Oh boy, now you see how ugly this is getting? Oh man. Well, here's the thing. Okay, so that right there, that's the work that I just did to do that left-hand side. And we end up with 9/4 x squared plus 9/2 x plus 9/4 equals this. Oh boy, we're going to have to take this over there. Then I start thinking like, I have a polynomial. And I have a bunch of fractions. And what I could do is just kill these fractions right now. In fact, if I multiply both sides of this equation by 4, I could kill all of those fractions. And so I'm going to go ahead and erase this work right here because it's right there. That's just the details. But what I could do. Now, I'm going through this the hard way, just to show you that you don't always want to just blindly follow rules. We'll talk about it in just a second. But I notice fractions. I don't like fractions, so I'm going to go ahead and multiply both sides by 4. The 4 kills that 4, giving me 9x squared. The 4 gets killed by the 2, leaving a 2. Giving me 18 x's. The 4 kills the 4, leaving me a 9. Okay, now this 4 distributes. 3x times 4 is 12 x's. 3 times 4 is 12. Okay. Oh boy, almost there. In fact, I'm going to go ahead. Rest up here. Now let's go ahead and simplify this a little bit more. We have 9x squared. He's going to have to stay there. So 9x squared. 18 x's. Let's move the 12 x's over. What's 18 minus 12? X should be plus 6x left over. The 9's on this side, minus 12 from that side. What's 9 minus 12?
Minus 3.
Minus 3 equals 0. How did I know to do that? Well, because I have a polynomial. I'm trying to solve for x. The best way of doing that is to get the polynomial equal to 0, because now we can factor this guy. And okay, I'm going to guess 3 and 3. So 3x and 3x. I don't know if that's a good assumption or not, but I'm just going to go with it and assume that that guy breaks down into a 3x and a 3x. The only way to get a 3 is a 1 and a 3. So how about a 1 and a 3? Now, what about my, I think I want a plus and a minus because I have a negative 3. So who gets the plus and who gets the minus?
The minus 3, I think.
Let's try it. Minus, so outer would give me negative 9x, inner would give me plus 3x for a total of negative 6x.
Okay, so
It's the other way around. You see, and yeah, like take a guess, right? And like the worst thing is that it works out the other way. And so outer gives me positive 9x, inner gives me minus 3x to give me plus 6x, which is what we want. Okay, I have factored this guy down. Factored this guy down. And so either this is equal to 0 or that is equal to 0. If the first is equal to 0, we have 3x minus 1 equals 0. Or in other words, 3x equals positive 1. Or x equals 1/3 is one possible solution. In the other case, we have 3x plus 3 equals 0, or 3x equals minus 3. Dividing both sides by 3 gives me negative 1. So there's another possible solution. This turned out to be really ugly because of these fractions, right? And the problem here is that I just blindly went ahead at this step and said, well, I got to get this guy by himself. I got to get that root by himself before I square it. But let's just see what would have happened if I didn't do that. So do you have all this written down? Do you have these numbers?
I'm almost finished.
Okay, let me know when you're ready because I want to go back and try something different. But I'd like for you to have all this down before we do that.
Okay.
Okay, so that is, I'm going to write this right here. 9x squared plus 6x minus 3 equals 0. All of our work ended up right there. And we knew that that gave us x equals 1/3 and x equals negative 1. Okay. Now let's just say I had gone back. And like I said before, right? If this happened to be, say, 6x plus 6, when I divide by 2, I would have something really nice, right? Or if this were 4x plus 8, if they're two even numbers, I could divide by 2 and I'd have nice whole numbers. But at this point, I could see that if I get rid of that 2, I'm going to end up with at least one fraction, right? And I know I'm about to square this out and things are going to get really ugly if I square it out. So what I'm going to do in this case, given that I would end up with fractions, I'm just going to go ahead and square both sides right here. Okay, now what is the right-hand side? What does that give me? It's this times itself. And so we could actually rearrange this, can't we? We could just say that's 2 times 2 times the root times the root. And so altogether, that gives me what?
4
Uh-huh.
times 3x plus 3.
Make sure you making parentheses your best friend, because really, like I said at the very beginning, whatever's in the root is technically in parentheses. And so we got to be careful with that. But yeah, that's that right there. The right-hand side, 3x plus 3 squared is 3x plus 3 times 3x plus 3. So first outer inner last gives me what on the left?
9x squared plus 18x.
Yes, plus 18x. And that's because the outer inner, right? We had 9x and 9x come together for 18x plus what?
Plus 9.
Plus 9. Man, this looks familiar. I wonder why this looks so familiar. X squared plus 18x plus 9 equals, well, how about we multiply this guy through? This gives me 12x plus 12. Oh man, boy, that's way easier than dealing with fractions. And we even ended up with the exact same thing. I'm gonna subtract 12x from both sides. Subtract 12 from both sides to give me 9x squared plus 6x minus 3 equals 0. Oh, look at that. So my point, and the reason I went into all of this, is that sometimes just blindly plugging along, like if you have rules in your head like I do, like, oh, get the square root all by itself. Sometimes that's the best way of doing it. But sometimes you end up with some crazy looking fractions. And I went ahead and did the multiply through by 4. But like, if you're doing this on your own, like, you're probably just going to be messing with fractions and messing with fractions. So my point is, you know what's about to happen at this point. You're going to have to square this guy out. And you know that if you divide an odd number by an even number, you're going to end up with a fraction. And so maybe there's a better way of going about doing it. And indeed there is. So I wanted to show you 2 ways of doing that. And just to know that if you did plug along blindly and divide by 2 first, like we did the first time, it's going to get ugly, but eventually you'll end up at the same answer. So all is not lost. It's just with the more of these you do, you'll start to notice, hey, there might be a better way of doing this one. So, okay, and then we didn't check it. I'm going to leave that to you. They both actually check. If you plug them in, they both work. And so in this case, we do get 2 solutions. 1/3 works and -1 works. And so, yeah, that's cool. But we got to move on because we are almost at the end of our hour. And I just went ahead and erased that. So sorry.
Okay.
Okay, cool. So one last example, and this was actually an example from the book. This was example 3 in the chapter, and it's x minus the square root of x plus 7 equals 5. So this is the only thing we haven't talked about yet. It's where we have x's and square roots. And as you might expect, it's very similar to what we just did, where we want to get the square root by itself. And so in this case, I'm going to say, all right, first of all, I don't like negative square roots. I don't like negatives if I could get away with it. So I'm going to get this guy on this side by adding him to both sides. That gives me x equals 5 plus the square root of x plus 7. I want to get that square root by itself. This is kind of like you could imagine we just had something with 2 square roots and we did some squaring and now we ended up with something like this. Same idea applies. We want to get this guy by himself. And so I'm going to subtract 5 from both sides. We get x minus 5 equals the square root. Now the square root is by himself, so I could square it and get rid of it. So I'm going to square this. I do that, and that gives me x plus 7. on that side. On the left-hand side, though, we're going to have to FOIL that guy out. First gives me x squared. Outer gives me minus 5x. Inner gives me minus 5x for a total of minus 10x's. Negative 5 times negative 5 is plus 25. Almost there. I'm going to subtract. Now I see, okay, I have a polynomial. Let's get it equal to 0. Hopefully it'll factor. X squared stays put. Minus an x gives me minus 11 x's. Minus 7, I believe, is 18. Let's see, 18, 19, 20, 21, 22, 23, 24, 25. Yes, okay, so that works. Okay, hopefully this will factor. Let's see. We have an x and an x. 18. 18 and 11. I'm thinking 18 is, we could try 2 times 9. I'm going to try it. 2 and a 9. Outer gives me 9x. Inner gives me 2x. That does indeed combine to give me an 11. So they're both going to need to be negative in order to give me the positive 18. And a minus 9 minus 2 does give me minus 11. Okay, good to go. So that means x is equal to what, or x is equal to what?
X is equal to 2 or 9.
Or 9. So let's finally check the original equation. If I plug in a 2, I get 2 minus root 2 plus 7. That gives me 2 minus 2 plus 7 is 7, 8, 9. 2 minus square root of 9 is 3. 2 minus 3 is negative 1, is not equal to 5. Ooh, so 2 is not one of them. Okay, let's check the other one. 9 minus the square root of 9 plus 7. Okay, that's 9 minus 9 plus 7, I believe, is 16. What's the square root of 16?
4.
What's 9 minus 4?
5.
And is 5 equal to 5?
Yes.
Yeah, last time I checked. So we do get one solution. So we've seen where there's no solutions. We've seen where there is only one solution, where you do all your work and you only end up with one solution. And that either works or it doesn't, in which case you have no solutions or you have one solution. There's this case right here where we pick up what's called an extraneous solution. We've done some magic here to this original equation, and something popped out that is not true at all. So we have to, this is why we have to check every single time. We can't assume that both answers are going to work. Sometimes none of them will work. Sometimes one of them will work, and sometimes both of them will work. But we have to check every single time. Okay. Any questions?
No, actually.
Okay, cool. So this stuff is, some of them are ridiculously involved, but it's very straightforward.
Mhm.
You're just solving equations, and really, and like, you know, I gave an overview and said, okay, first you want to split up. If you have 2 roots, get them on opposite sides, and then you could just brute force square everything out from the very beginning and it's going to work. It's just going to get ugly. And so have fun. Okay, here's your homework. This is all due on Monday. So it's only Monday. It's a total of 16 questions. This is chapter 7, section, what is this? 6. On pages 319, 320. Numbers. 5, 11, 15, 19, 21, 25. Okay. 29 through 39 odd. That is 12 questions. And you have 4 more. 47. 49. 50 and 50. 50 is ridiculously hard. And
Right.
all I'm looking for with 50 is I just want to see some scratch work. I would like you to attempt it because it's supposed to be hard. Like you're not supposed to know how to do this. I would like to see you just try. Scratch work and then maybe some explanations like I tried to do this, thought it might give me this, but I ended up with this. And so I want to see scratch and maybe some minor explanations. For 52, no. Oh, it was 49. Okay, here's the key for 49. You're going to have something in the sixth root. Write it as something to the sixth power. This will help. If you don't do that, like I did, you're going to have a hard time. It will make your life so much easier to do that. And remember, if you have something like this finally, I know we're over time, but if you have, say, oh, I don't know, let's go 1/10, and you raise that thing to the power of, say 5. So you have an expression like this, and you raise it to the 5th power. Like we talked about last time, that's the same thing as 5/10. Raising something to a power, that is where you multiply those two numbers. And so this should be enough to get to prevent you from making the mistake that I made. This will help you. And 5/10 reduces down to, I think it's 1/2, which should make your life way easier. So that's for 49. 50, scratch work. I want to see you attempt it and some reasoning behind it. And the rest of it should be pretty straightforward.